Hey, curious minds, get ready for mind-blowing facts about animals, science, and more. From surprising talents to bizarre discoveries, this video is packed with fun you won't believe. Sit back, relax, and let's dive into the unexpected.
The speed of a computer mouse is measured in a unit called Mickeys. This quirky term originates from the early days of computer technology and is named after Mickey Mouse, likely as a playful reference to movement and tracking. A Mickey is defined as the smallest detectable movement of a computer mouse, typically about 1/200th of an inch or 0.1 millimeters. This unit is used to measure the distance the mouse travels in relation to cursor movement on the screen. Mickeys are particularly useful in the realm of computer engineering and gaming to fine-tune mouse sensitivity settings. The measurement is often expressed as Mickeys per second, which quantifies the speed at which the mouse is moved. For example, if a mouse moves 500 Mickeys per second, it means that the sensor detects 500 tiny increments of movement within that time frame. This unit helps determine how precisely a mouse translates physical motion into digital input, making it an important factor in high-performance gaming, graphic design, and other precision-based tasks. The concept of Mickeys plays a crucial role in mouse acceleration and sensitivity settings. Different operating systems and software applications use these values to control how fast the cursor moves in response to physical motion. By adjusting the Mickey per pixel ratio, users can fine-tune their mouse experience, ensuring smoother or more rapid movements depending on their needs. Although the term Mickeys is not commonly referenced in everyday computing, it remains an integral part of how mouse movement is measured and optimized in modern technology. Would you like to know more about how this applies to gaming or design settings?
An octopus's tentacle, more accurately called an arm, is a marvel of nature, containing more neurons than a human brain. While the entire octopus has around 500 million neurons, roughly 2/3 of them are located in its 8 arms rather than its central brain. In contrast, the average human brain contains about 86 billion neurons, but all of them are centralized in the head. This decentralized nervous system allows octopus arms to think, sense, and react independently, making them some of the most complex and versatile appendages in the animal kingdom. Each octopus arm has around 40 to 50 million neurons, enabling it to perform sophisticated tasks without needing constant input from the brain. In some cases, an arm can continue moving, exploring, or even trying to escape for a short time after being severed. This autonomy allows octopuses to multitask in extraordinary ways. For instance, an octopus can use one arm to probe a crevice for food, while others engage in camouflage, movement, or even problem-solving. The arms can also taste and smell their environment thanks to thousands of chemosensory suckers, giving the octopus an unparalleled ability to interact with its surroundings. This incredible nervous system makes octopuses highly intelligent creatures capable of solving puzzles using tools and escaping enclosures with surprising skill. Scientists often compare the octopus's nervous system to an alien form of intelligence, as its structure is vastly different from that of vertebrates. The combination of a semi-autonomous nervous system, advanced problem-solving skills, and unparalleled dexterity makes the octopus one of the most fascinating creatures in the ocean. Would you like to dive deeper into how octopuses use their intelligence in the wild?
A single teaspoon of honey might not seem like much, but it actually represents the entire lifetime work of approximately 12 honeybees. This incredible fact highlights the dedication, teamwork and efficiency of honeybee colonies, which work tirelessly to produce this liquid gold. Honey production is a complex process that begins when worker bees, also known as foragers, collect nectar from flowers. They use their long tube-like tongues to suck up the nectar and store it in their honey stomachs, a specialized organ separate from their digestive system. Enzymes in the honey stomach begin breaking down the nectar's complex sugars into simpler ones, preparing it for storage. Once the foragers return to the hive, they pass the nectar to house bees through a process called trophallaxis, a mouth-to-mouth transfer. House bees then continue breaking down the sugars and deposit the nectar into the wax honeycomb cells. To transform the nectar into honey, bees fan their wings rapidly, creating airflow that evaporates excess water, thickening the nectar into honey. Once the honey reaches the right consistency, around 17 to 18% water content, the bees seal the cell with wax, preserving it for future use. Each individual bee produces only a tiny fraction of a teaspoon of honey in its entire lifetime, about 1/12 of a teaspoon. This means that it takes the collective effort of 12 bees each, foraging for nectar throughout their entire lifespan of about 6 weeks, just to make a single teaspoon of honey. To put it in perspective, a single bee must visit around 2,000 flowers per day and may travel up to 5 miles from the hive during a single foraging trip. A healthy bee colony can contain 50,000 to 60,000 bees, working together to produce 30 to 100 pounds of honey per year. However, much of this honey is consumed by the bees themselves, providing them with energy to survive through the winter when flowers are scarce. Beekeepers carefully harvest only the excess honey, ensuring the hive has enough to sustain itself. The fact that it takes 12 bees a lifetime to produce just 1 teaspoon of honey underscores the importance of protecting honeybee populations. Bees not only make honey, but also play a critical role in pollination, helping plants, fruits and vegetables reproduce. With habitat loss, pesticides and climate change threatening bee populations, every teaspoon of honey is a reminder of the immense effort and contribution of these small but mighty creatures.
Quantum entanglement is one of the most mind-bending and fascinating concepts in physics. It describes a phenomenon in which 2 or more particles become interconnected, meaning their properties are instantaneously correlated, no matter how far apart they are. If one particle's state is measured, the other particle's state will instantly change accordingly, even if they are separated by light years or entire galaxies. This bizarre effect appears to defy classical physics and has puzzled scientists, including Albert Einstein, who famously called it spooky action at a distance. In the quantum world, particles such as electrons or photons can become entangled when they interact in a specific way. Once entangled, their quantum states, such as spin, polarization, or momentum, become linked, even if these particles are later separated by vast distances. Measuring the state of one will instantaneously determine the state of the other. For example, imagine 2 entangled electrons with opposite spins. If one electron is measured and found to have an up spin, the other electron's spin will immediately be down, no matter how far away it is. The key mystery here is that the second electron's spin isn't just determined at the moment of measurement. It seems to have been set instantly, defying the normal speed limits of communication, including the speed of light. Einstein was deeply skeptical of quantum entanglement. He and his colleagues, Boris Podolsky and Nathan Rosen, proposed the EPR paradox, Einstein-Podolsky-Rosen paradox, in 1935, arguing that quantum mechanics must be incomplete. They believed that hidden variables must exist, unseen information determining the state of each particle before measurement. However, in the 1960s, physicist John Bell developed Bell's theorem, which showed that no hidden variable theory could fully explain quantum entanglement. Experiments performed since then, most famously by Alana Specht in the 1980s, confirmed that entanglement is real and cannot be explained by classical physics alone. This meant that the universe operates in ways even stranger than Einstein had imagined. One of the most puzzling aspects of entanglement is its instantaneous nature. The fact that a particle's state changes across vast distances suggests some form of faster-than-light interaction. However, entanglement cannot be used for faster-than-light communication because no actual information is being sent. Only correlations between particles are observed when measurements are made. The results still appear random until both parties compare their data through conventional communication, which is limited by the speed of light. Although entanglement seems like a purely theoretical curiosity, it has real-world applications in emerging technologies. Quantum computing. Entanglement is key to quantum computers, allowing them to process information exponentially faster than classical computers. Quantum cryptography. entangled particles enable ultra-secure communication, as any attempt to eavesdrop would disrupt the system and be immediately detected. Quantum teleportation. Scientists have successfully teleported quantum states using entanglement, a potential breakthrough for future quantum networks. Quantum entanglement challenges our fundamental understanding of reality. It suggests that the universe may be deeply interconnected, with information and influences extending far beyond classical space-time. Some theories even propose that entanglement could be linked to the fabric of space itself, hinting at deeper connections between quantum mechanics and gravity. While quantum entanglement remains one of the greatest mysteries in physics, its implications for technology, philosophy, and our understanding of reality are profound. As scientists continue exploring this phenomenon, we may uncover even more astonishing truths about the nature of the universe.
The term computer bug is widely used today to describe software glitches and hardware malfunctions. But the origin of the phrase is quite literal. The first documented computer bug was an actual insect, a moth, discovered in 1947 inside a computer at Harvard University. This seemingly trivial event has since become a legendary moment in computing history. The bug was found in the Harvard Mark II, an early electromechanical computer used for complex calculations. This massive machine, which used relays, vacuum tubes and switches, was being operated by a team of engineers, including the renowned computer scientist Grace Hopper. One day the machine started experiencing unexplained errors. After some investigation, the engineers opened the computer's panels and discovered that a moth had become trapped inside one of the machine's relays, causing it to malfunction. The team carefully removed the moth and taped it into the computer's logbook with a note describing it as the first actual case of a bug being found. Although Grace Hopper is often credited with coining the term debugging due to this incident, the word bug had actually been used in engineering long before computers existed. Thomas Edison, for example, used the term in the late 1800s to describe mechanical issues in his inventions. However, the Harvard Mark II moth incident became the most famous use of the term in the context of computing, solidifying bug and debugging as standard technical jargon. Today, software bugs are an inevitable part of programming, but the concept of debugging, systematically finding and fixing errors, remains central to computing. The original moth is now preserved in the Smithsonian Institution, serving as a reminder of how even the tiniest creatures can influence technological history. While modern bugs are mostly coding errors rather than actual insects, the first bug remains a fascinating and humorous moment in the evolution of computing. It also highlights the ingenuity of early computer engineers, who had to physically inspect and repair machines in ways that today's programmers rarely need to do.
Diamonds rain on Jupiter and Saturn, a cosmic gemstorm. The idea of diamond rain on Jupiter and Saturn sounds like something from a science fiction story, but it is actually grounded in real planetary science. Due to the immense pressure and extreme atmospheric conditions on these gas giants, scientists believe that diamonds can form and fall through their atmospheres like rain. This fascinating phenomenon is a result of chemical reactions, intense heat and crushing pressure deep within these planets. How are diamonds formed in Jupiter and Saturn? Unlike Earth, where diamonds are formed deep in the mantle over millions of years, the process on Jupiter and Saturn is much more dynamic and violent. These planets have thick, turbulent atmospheres primarily composed of hydrogen and helium, with significant amounts of methane. Methane turns to carbon. In the upper atmosphere, lightning storms and high-energy collisions break down methane molecules, or CH4, into their basic component carbon. Carbon transforms into soot and graphite. As the free carbon falls deeper into the atmosphere, the intense pressure causes it to clump together, forming tiny, black soot particles. As these particles descend further, the pressure increases dramatically, reaching thousands of times the atmospheric pressure on Earth, causing the carbon to compress into graphite, just like the material found in pencils. Graphite turns into diamonds. As the graphite continues to fall, it reaches a depth where the pressure is so high that it crystallizes into diamonds. These diamonds can grow to impressive sizes, potentially reaching centimeters or even larger before they continue sinking deeper into the planet. The fate of falling diamonds. While diamonds can form and rain down, they don't last forever. As they continue their descent into even greater depths, the extreme temperatures, up to thousands of degrees Fahrenheit, eventually cause them to melt into liquid carbon, effectively creating a vast ocean of liquid diamond in the deeper layers of Saturn and Jupiter. Other planets that might have diamond rain. While Jupiter and Saturn are the most well-known candidates for diamond rain, some scientists believe that similar processes could be happening on Uranus and Neptune as well. In fact, because Uranus and Neptune have even higher carbon concentrations, they might have even more extensive diamond rain, possibly leading to entire layers of solid diamond deep within their interiors. Could we ever collect space diamonds? While these diamonds exist in abundance on Jupiter and Saturn, retrieving them would be nearly impossible due to the harsh conditions and crushing pressures deep inside the planets. However, studying these processes helps scientists understand the complex chemistry of planetary atmospheres and could offer clues about the formation of exoplanets across the universe. A cosmic wonder. The idea that diamonds, one of Earth's most valuable and sought-after gems, fall from the sky on Jupiter and Saturn is a fascinating reminder of how different and extreme other worlds can be. While diamonds on Earth are rare and precious, on these gas giants they are a natural byproduct of planetary physics, raining down in a spectacular cosmic storm.
Wi-Fi signals can be disrupted by fish tanks. The science behind it. It may sound surprising, but fish tanks can interfere with Wi-Fi signals, leading to weaker connections, or even complete signal drops. This happens because of how water interacts with radio waves, especially at the frequencies commonly used for Wi-Fi networks. If you've ever noticed slow internet speeds near a large aquarium, there's a good scientific reason for it. How Wi-Fi works and why it's affected by fish tanks. Wi-Fi signals are a type of radio wave specifically operating in the 2.4 GHz and 5 GHz frequency bands. These signals travel through the air in a straight line, bouncing off surfaces and passing through some objects, but they can also be absorbed or blocked by certain materials. Water, especially in large amounts like a fish tank, is very effective at absorbing radio waves. 1. Water absorbs electromagnetic waves. Water molecules are polar, meaning they have a positive and negative end. This allows them to interact with electromagnetic waves, absorbing energy from the signal. The 2.4 GHz Wi-Fi frequency is particularly close to the resonant frequency of water, meaning water absorbs a significant amount of this signal. That's why microwave ovens, which operate at 2.45 GHz, can efficiently heat food containing water. 2. Signal reflection and scattering. Fish tanks are often made of glass, which itself can reflect and distort Wi-Fi signals. Water inside the tank scatters the signals, causing them to weaken or even fail to reach their intended destination. The larger the tank, the greater the disruption. A fish tank can block Wi-Fi signals if it's placed between your router and your device. Some common scenarios where this might happen include a fish tank near the router. The signal strength is significantly reduced because most of the Wi-Fi waves are absorbed. A fish tank between the router and your device. The signal might be distorted or weakened, leading to slower speeds or connection drops. Wi-Fi router placed behind or next to a large aquarium. The signal may be almost entirely blocked, making it hard for devices in another room to receive a strong connection. How to minimize fish tank Wi-Fi interference. If you have a fish tank and notice Wi-Fi problems, here are some solutions. 1. Reposition your router. Place the router in a higher location, away from the fish tank. Avoid positioning it directly behind or next to the aquarium. 2. Use the 5 GHz band. The 5 GHz Wi-Fi band is absorbed by water less efficiently than 2.4 GHz, meaning it may perform better in homes with large aquariums. However, 5 GHz signals have a shorter range, so their effectiveness depends on your home layout. 3. Upgrade to a mesh network. Mesh Wi-Fi systems use multiple nodes to distribute signals around obstacles like fish tanks. This helps improve connectivity in tricky environments with many obstructions. 4. Use a wired connection. If your router is near your fish tank, consider using Ethernet cables for devices that require a stable connection. A quirky yet real Wi-Fi challenge. While it may sound strange, the science behind Wi-Fi and water interactions makes it clear why large bodies of water, including fish tanks, can disrupt wireless signals. Understanding this can help improve home Wi-Fi performance and ensure that both your internet connection and your fish stay happy.
The highest officially recorded temperature on Earth occurred on July 10, 1913, in Furnace Creek, California, a location within Death Valley, one of the most extreme environments on the planet. The temperature that day reached a blistering 134 degrees Fahrenheit, or 56.7 degrees Celsius, a record that still stands more than a century later. Death Valley is one of the hottest places on Earth due to a combination of geographical and atmospheric factors. Low elevation, Furnace Creek sits at 190 feet or 58 meters below sea level, meaning the air pressure is slightly higher, which can trap heat more effectively. Surrounding mountain ranges, the valley is surrounded by mountains, which create a rain shadow effect, preventing moisture from reaching the region. This lack of humidity reduces cloud cover, allowing the sun's rays to directly heat the valley floor. Desert surface and heat retention. The valley floor consists of dark rocks, sand, and salt flats, which absorb and retain heat. At night, the heat is slowly released, meaning temperatures remain high even after sunset. Dry air and lack of vegetation. With almost no moisture in the air, there is very little evaporative cooling, unlike in humid regions where sweat and water can help regulate temperature. The barren landscape means there are no trees or plants to provide shade. Although 134 degrees Fahrenheit is the official world record, some meteorologists have questioned its validity. Critics argue that the temperature reading might have been a recording error due to the equipment used at the time. Weather conditions on that day didn't fully match expectations for such extreme heat. More recent records suggest that temperatures in Death Valley rarely reach that high, even in modern times with better instruments. Despite these concerns, the record remains officially recognized by the World Meteorological Organization. Even if the 1913 record were to be disputed, Death Valley continues to break heat records. Modern highest temperature. On August 16, 2020, Furnace Creek recorded 130 degrees Fahrenheit, or 54.4 degrees Celsius, the highest verified temperature in the last century. This is the hottest reliably recorded temperature in modern times, given improvements in measurement technology. Hottest overnight low temperature. On July 12, 2012, Death Valley recorded an overnight low of 107 degrees Fahrenheit, or 41.7 degrees Celsius, making it the hottest nighttime temperature ever measured. Earth's hottest natural temperature, 134 degrees Fahrenheit, is scorching, but it pales in comparison to other planets. On Venus, the surface temperature is a consistent 867 degrees Fahrenheit, or 464 degrees Celsius, due to its thick atmosphere trapping heat. Mercury, the closest planet to the Sun, experiences daytime highs of 800 degrees Fahrenheit, or 427 degrees Celsius, but plunges to minus 290 degrees Fahrenheit, or minus 180 degrees Celsius, at night. With climate change driving global temperature increases, many scientists warn that extreme heat events could become more frequent and severe. Some models predict that, in the coming decades, regions like the Middle East, South Asia, and parts of the US Southwest could see even higher temperatures, possibly surpassing the 1913 record under the right conditions. If you ever find yourself in an extreme heat event, survival depends on proper hydration, shade and cooling measures. Death Valley's visitors are advised to avoid hiking after 10 a.m., carry extra water, and recognize heat stroke symptoms.
The sulfur in your body enough to kill all fleas on a dog. Sulfur is a crucial element in the human body, playing a role in various biological processes. It is one of the essential elements for life and is found in every cell, tissue and organ. Surprisingly, the total amount of sulfur in a human body, about 140 grams or 5 ounces in an average adult, is enough to kill all fleas on an average-sized dog if it were used in its toxic form. Why does your body contain sulfur? Sulfur is present in many proteins, enzymes and vitamins that keep your body functioning properly. Some of its key roles include building proteins. Sulfur is a component of essential amino acids like cysteine and methionine, which are necessary for forming proteins in your muscles, skin and hair. Strengthening hair, nails and skin. Keratin, the protein that makes up your hair and nails, contains high amounts of sulfur, giving these structures their strength and durability. Detoxification. Sulfur plays a key role in the liver's detox processes, helping to remove harmful substances from the body. Antioxidant function. It is a component of glutathione, one of the body's most powerful antioxidants that protects cells from damage. Joint health. Sulfur is necessary for the production of cartilage, which keeps joints healthy and flexible. How can sulfur kill fleas? Sulfur has been used as a natural pesticide for centuries. When applied in its elemental or chemical form, sulfur disrupts the metabolism of small insects like fleas, mites and lice, effectively killing them. Toxic to fleas. Sulfur interferes with flea reproduction and can kill them on contact in high enough concentrations. Sulfur is used in pet care. For example, some flea shampoos and powders contain sulfur because it is a natural alternative to synthetic pesticides. Now, when it comes to humans, sulfur is safe in normal doses. While the sulfur in our bodies is essential for life, excessive amounts can be harmful. However, under normal conditions, the sulfur in your body is bound in proteins and not toxic like raw sulfur powder. Sulfur-rich foods in your diet. Your body gets sulfur mainly through diet, especially from foods rich in certain amino acids and compounds. Common sulfur-rich foods include protein sources, eggs, meat, fish, and dairy. Vegetables, garlic, onions, cabbage, broccoli, and Brussels sprouts. Legumes, lentils, chickpeas and soybeans. Nuts and seeds, sunflower seeds and Brazil nuts. Fun perspective. How much sulfur is in your body? To put this in perspective, the average human body contains 140 grams or 5 ounces of sulfur. An average dog flea weighs about 0.45 milligrams. A dog may have hundreds or thousands of fleas in a severe infestation. If all the sulfur in your body was somehow extracted and converted into its toxic form, it would theoretically be enough to wipe out an entire flea infestation on a dog. While this fact sounds shocking, it simply highlights how sulfur, an essential element in our bodies, can also be deadly to certain small organisms. Our body's natural chemistry plays a fascinating role in everything from metabolism to pest control.
Uranium is one of the densest naturally occurring elements on Earth. A single cubic foot of uranium weighs an astonishing 1,190 pounds. That's more than half a ton in a space no bigger than a small microwave. This extreme density makes uranium highly valuable in both energy production and military applications, as well as an interesting subject in physics and engineering. The reason uranium is so dense lies in its atomic structure. Uranium has an atomic number of 92, meaning each atom contains 92 protons in its nucleus. It also has a high atomic mass due to the presence of many neutrons. The most common isotope, uranium-238, has 146 neutrons. These tightly packed particles create an incredibly heavy and dense nucleus, making uranium one of the heaviest naturally occurring elements on Earth. For comparison, here's how uranium's density stacks up against other materials. Water, 62.4 pounds per cubic foot. Aluminum, 168.5 pounds per cubic foot. Lead, 708 pounds per cubic foot. Uranium, 1,190 pounds per cubic foot. Gold, 1,206 pounds per cubic foot. Osmium, the densest metal, 1,411 pounds per cubic foot. While uranium is denser than lead, it is slightly less dense than gold and significantly less dense than osmium and iridium, the densest known elements. The high density of uranium has several practical applications. First, nuclear energy uranium is best known as the primary fuel for nuclear reactors. The isotope uranium-235 or U-235 undergoes nuclear fission, releasing vast amounts of energy used to generate electricity. Second, military armor and ammunition. Due to its density, uranium is used in armor-piercing rounds and military tank armor, often in the form of depleted uranium, or DU, which is a byproduct of uranium enrichment. DU is denser than lead, making it highly effective in penetrating enemy vehicles and fortifications. Lastly, counterweights and shielding. Because uranium is both extremely dense and capable of blocking radiation, it is used in counterweights for aircraft, as well as in radiation shielding for medical and industrial applications. To put 1,190 pounds per cubic foot into perspective, a cubic foot of uranium weighs as much as a grand piano or a polar bear. If you had a gallon-sized block of uranium, it would weigh around 150 pounds, about as much as an average adult human, and a basketball-sized piece of uranium would be nearly 200 pounds, almost impossible to lift. Despite being radioactive, natural uranium emits low levels of radiation and is not highly dangerous to handle in solid form. The real dangers arise when uranium is inhaled or ingested, as radioactive particles can damage cells and increase cancer risks over time. Additionally, uranium's extreme weight means handling large amounts can pose physical dangers due to its sheer mass. Uranium's remarkable density makes it one of the heaviest and most fascinating elements on Earth. Whether used for nuclear power, military applications, or industrial purposes, its sheer mass and atomic structure make it a truly unique and valuable resource. Despite its radioactive nature, uranium continues to be a crucial element in both energy production and scientific research, shaping modern technology and global industries.
Thanks for watching. We hope you enjoyed these incredible facts. If you found them fascinating, there's so much more to discover. Stay tuned for our next video, where we uncover even more mind-blowing facts about the world around you. You won't believe what's next.